Good day, learners. In this video, we are going to do revision of grade 11 analytical geometry before we are going to start then with the grade 12 analytical. Before we jump in, I just want to show you on your formula sheet the formulas that you did in, well, this is actually grade 10, 11 analytical geometry. In grade 10, you learned of the distance, midpoint, and gradient formula. The distance formula to calculate the length between 2 points or the distance between 2 points. The midpoint formula that calculates the coordinates of the midpoint between point 1 and point 2, xy, xy. And then the gradient formula, you also worked with the straight line equations. They are on your formula sheet. And then in grade 11, you learned about inclination, m is tan theta. Just two things I want to mention. I think most of you know very well how to use these formulas. In grade 12, we are going to look at the circle, the equation of a circle at point with the center at coordinates a, b. That's in this formula, and the radius r. But we'll look at that soon enough. I just want to mention two things. The one thing is on gradients, and the second thing is on the inclination. Before we look at some questions. On gradients also, this is not on your formula sheet, but this is something you should really know, is that gradients that are equal, if the gradient of one line is equal to the gradient of the other line, then those lines, the gradient of one line equal to the gradient of the other line, that means that these two lines are parallel to one another. Or whenever you have parallel lines, this works both ways actually. Whenever you have parallel lines, like in a parallelogram or a square or a rectangle, those are parallel lines, then obviously also the gradients will be equal. This you worked with in grade 10, 11. And the second thing is that if two gradients multiplied gives you -1, then that means that the two lines with these gradients will be perpendicular to one another, and also backwards. If the two lines are perpendicular, that means obviously then that the gradients multiplied should give you -1, and you can use this to calculate the missing gradient as well. So this is on gradient, something that you should know. On inclination, inclination is tan theta is equal to m. It's just important that you know that this theta, the inclination angle, is always the angle that's formed from the positive x-axis in an anti-clockwise direction. So if I have a line here, even though this line cuts the x-axis at a negative direction, you can think of a little cast diagram. Just like the cast diagram goes 0, 90, 180, 270. From the positive x-axis side, the angles are formed in that direction. The angle of inclination is measured exactly like that. So from the positive x-axis side in an anti-clockwise direction to the line, that would be your angle of inclination, theta or alpha or whatever. So if I have a line there, this from the positive x-axis side to the line would be my angle of inclination, just so you know where to find that angle of inclination. And even if a line does not cut the x-axis, so say I have a line there, and it doesn't, well, it would cut the x-axis if you continue, but on the sketch it doesn't cut the x-axis here. You can always just go and draw a little cast diagram there and find the angle of inclination like that. So there's the angle of inclination of that line, just so you know When I talk about inclination, I mean from the positive x-axis in an anti-clockwise direction. That's the first thing, where to find the angle of inclination. That's quite important. The second thing with inclination that's quite important is you must just remember when the line lies forward like this, like there's 90 degrees, if it lies anywhere forward in that direction, like a forward direction, this will be a positive gradient, as hopefully you know, and then the angle of inclination is an acute angle. If you think of this little cast diagram here, you see this angle lies between 0 and 90. It's an acute angle, where if the line lies backwards, this is a negative gradient. And you can see if you draw your little cast diagram there, 0, 90, 180, you see this line actually goes past the 90 and lies between 90 and 180, and this angle will actually be an obtuse angle. So if you work out this angle, say the gradient of this line is -1, just to make it easy, you can do one of two things. If the gradient is negative, because you see, if I press in my calculator shift tan, say the gradient is -1, so I press shift tan -1, it gives me -45. Now this angle there, obviously not -45, so you can either say 180 minus 45, so just add 180 to that, then it's 1, that's 135, or you can use the positive shift tan. The gradient is -1 there, but I use the positive value of the gradient 1. That gives me the acute angle of 45, and then to get, that's that angle actually then, and then I take 180 minus the 45 to get the 135, which is that angle. What is important here is just whenever you have a negative gradient, you must just remember to take 180 minus the acute angle to actually get that obtuse angle there. Alright, okay, so I'm going to do a few examples. This is from the answer series, Analytical Geometry, on page 1.33. I want to do questions 7, 8, and 13 in this video. Question 7 is not your typical analytical question, but there is one or two few interesting things that comes across here that I just want you to also notice. So we're going to do this first. It's not your typical question, but we can look at this. Okay, so this one says, in the figure, QRST is a parallelogram with vertices Q and T lying on the y-axis. So this is a parallelogram, and the points Q and T are exactly on the y-axis, and you can see there on the T as well, it's T03. Okay, on the y-axis, the side RS is produced to U such that RS is SU. RS is produced to U such that RS is equal to SU, those two lines. The length of QT is 4 units. Now, obviously, since this is a parallelogram, if that's 4 units, this is also 4 units. And since they told me this is equal to that, I can already see that this is 4 units, this is 4 units, all of that. So that helps me greatly. And the coordinates of R and T are 9, 9, and 0, 3 respectively. The coordinates of R is 9, 9, the coordinates of T 0, 3. The line segment QU intersects TS at W. The line segment QU intersects TS at the point W there. Determine the coordinates of Q and U. Okay, so first let's determine the coordinates of Q and U. Now this is not very difficult. The tactics I use are not really going to use analytical geometry formulas here. I'm going to say, because this is on the y-axis and this is also on the y-axis, the x is automatically 0. To get the y, I can just see this cutting point there is 3, and then 4 units up will be 7. So Q is going to be the 0.07, just by thinking a bit logically on what is on the sketch there. So I can start off here 7.1.1. Q is the 0.07, and 7.1.2, I want also the coordinates of U there. Now, there's two things you can do here. The first thing is, you know, this is a parallelogram, so this will be parallel to that, meaning this line here is exactly 90 degrees to the x-axis, because I'm in the y-axis also, and those have the same gradient, or those lines will be parallel, so they're both perfectly vertical lines there. Now, since my x value there is 9, everywhere on this line, my x value is going to be 9. So even at S, even at U, so the x value at U is going to be 9. And then since I know, I said already, this is 4 units, because of properties of a parallelogram, that's 9, so it go down 4 units, then it's at 5. Go down another 4 units, then that is at 1. So the coordinates of U is 9, 1. That's one thing you can do. I just want to show you something else that might be useful to know. I know in this question, I mean, it's straight up, so the distance I can just exactly work out. It's straight up, but it's a handy trick to know in a parallelogram. What happens to the coordinates from there to there is the same thing that happens from there to there. And also what happens to the coordinates from there to there is the same what happens from there to there. So, for instance, if Q, I just want to quickly draw this parallelogram here so that I can write on it. I don't want to write in the textbook here now. So I have the coordinates T0, 3 there, and the coordinates of Q, which is 0, 7, as I said. And I have the coordinates R, which is 9, 9. Quickly look at what happens here. What happened from the x to the x? From 0 to 9, I moved 9 forward. So from 0 to 9, I'm going to move 9 forward as well. And then from 7 to 9, I moved 2 up. And from 3 to 5, I moved 2 up. So exactly what I do there, I can do here as well, if this is a parallelogram. Right, and you see as well what happened from, I now used what happened from there to there is the same that happens from there to there, but the same thing here. What happens from 0, 3 to 0, 7, nothing in the x values, but the y values went up by 4. You see here, nothing in the x values, the y values went up by 4. And this is just a handy trick to know when working with parallelograms as well. All right, let's continue. Question 7.2. Determine the equation of the line OR. Okay, so OR there. This is not a very difficult equation. You don't really even need to use a straight line formula, because a line that goes through the origin, through the point 1, 1, 2, 2, 3, 3, 4, 4, up until 9, 9, 10, 10 is just y is equal to x. Actually, that line, and I know that, so I don't really need to do calculations. The equation is y is equal to x, but just to show you using the two different formulas that's on your formula sheet, I just want to also quickly run through that. The one formula is y is equal to mx plus c. Then I'm going to use the m formula, difference in y. So I'm going to use the points 0, 0 and 9, 9 to calculate the equation of OR. Okay, so this is very easy stuff, I think, for most of you to do. But just to for the sake of the learners who's still not sure of how this works, I just quickly want to run through this, because there's so many places in math where you can actually get marks by just determining line equations. It's really important that you're comfortable with calculating line equations. So difference in y, my two coordinates are 0, 0 and 9, 9. So the difference in y is 9 minus 0. 9 minus 0 over 9 minus 0, which is the difference in x as well. And then this is, well, 1. Okay, so my gradient is 1. Then I have y is equal to 1x plus c. So I have my gradient. And then if I substitute my gradient into the equation plus any point. So I have 2 points. You can substitute any one of the 2 points. Let's substitute the 9, 9. So I'm going to make y is equal to 9 and x is equal to 9 plus c. And then this works out so that c is 0. So m is 1 and c is 0. Then y is equal to m, which is 1x, plus c, which is plus 0. And I don't need to write that. The equation is y is equal to x. Okay. The other formula on your formula sheet, I don't really like with working with this formula, but yeah, it's just for the purposes of those that wants to know how that works. Is this y minus y1 is equal to m, x minus x1. Y is equal to, minus y1 is equal to m, x minus x1. Okay, so how this works is, yet again, you're going to need the gradient here, which you calculate the same way. It's going to be 1. Then I have y minus y1 is equal to 1, x minus x1. And then I substitute the point into there, x1 and y1. So yet again, you can choose any of these 2 points. Let's choose the 9 again. So I have y minus 9 is equal to x minus 9. And then just simplify this equation so that you have it in the form y is equal to mx plus c. If I take over the 9, I'm going to have minus 9 plus 9, which falls away, leaving me only then y is equal to x. So you can work with either one of those, but there is my equation, y is equal to x. That's not a very difficult one. 7.3. Now, if W is the point, is the midpoint of UQ, determine whether W lies on the line OR, meaning whether OW and R are collinear. So if W is the midpoint of UQ, there's UQ. I have the coordinates of Q and U. I want to know what is the coordinates of W, which is the midpoint of QU. So let's find the coordinates of W, which is the midpoint. I'm going to just use the midpoint formula there. The midpoint of QU on my formula sheet is x1 plus x2 over 2, y1 plus y2 over 2. And then I'm going to use x1, y1 as Q summer. So Q is the 0.07 and U is the 0.91. Okay, so I want to take the two x values added, 0 plus 9, there 0 plus 9 over 2, and the two y values, 7 plus 1, 7 plus 1 over 2, which is then 9 over 2, 8 over 2, or 4.5, 4. 9 over 2 and 4, which means that W does not lie on OR, because the equation of OR is y is equal to x, and this y is not equal to x. So if you substitute this x value in there, it does not produce this y value. So yeah, okay, not collinear. Okay, so that's question 7. This is not a really difficult question. We are just revising actually through grade 11, 10, 11 work. So none of this should be really challenging for you. And analytical is a very achievable topic. It's not crazy difficult, but there are some little things that they can catch you out with. So it's worth it just to make sure you are comfortable enough with this topic that you can get actually all of the marks, because it's a place where you can score easy marks. Let's look at question 8. I'm going to just see if I can take the camera a little bit closer to the textbook, because it feels to me like you can't really read properly what's standing there. I think that's a bit better. I hope it's not too close for the writing now, but we'll see. Okay, so it says here in the figure, it's still a bit blurry. There it's better. Oh, I don't know. Okay. Okay. In the figure, ABC is a triangle. There we are. With vertices A, 2, 5. It's shown on the sketch. B, minus 4, minus 1, and C are the vertices. T, 1, 3 is the point of intersection of the altitudes. T there, 1, 3. The intersection of the altitudes, the perpendicular heights from A, B, and C, meaning from A, if I draw a perpendicular height, this point T lies on that height, but also from C, if I draw a perpendicular height to that line, it's going to go through that point and from there. So all of the, altitudes go through that point. It might be important for the sketch. Okay. I hate that this is so blurry. That's a bit better, but now I must hold the book there. Okay. The inclination of AB, there it's shown on the sketch is theta. Of AB to the x-axis is theta. The equation of the line passing through C and T is given by y is equal to minus x plus 4. So the line going there through C and T has an equation minus x plus 4. Determine the length of AB. Okay, now AB, I have the coordinates 2, 5, B minus 4, minus 1. So to determine the length of AB is not really difficult. I'm just going to use the distance formula there. Okay, so I have the point A. I'm just going to write it here so you can all see that very clearly. B is negative 4, negative 1. This is on the sketch and they want me to calculate the length of AB. So I'm just going to use the distance formula, which is the square root of difference in x squared plus difference in y squared, and the difference in x here is difference in x is minus 4, subtract 2, negative 4, subtract 2 squared, plus negative 1, subtract 5, negative 1, subtract 5 squared, and just type that into your calculator. Please don't show 5, 6, 7 steps here, because it's really not necessary. It opens you up to making mistakes, and it doesn't really count marks in grade 12. You don't even get a mark for the formula, because the formula is on your formula sheet. Although, just to mention, if you start with the wrong formula, the incorrect formula, then it's no marks. So you should use the correct formula, but you don't get a mark for it. Substitution answer, 2 marks. The length of AB here in this question, indeed 2 marks. So just type it into your calculator, and then the calculator gives me 6 root 2, which actually you should normally press that SD button and write it rather as 8.49. But in this question, they said specifically leave the answer in simplest surd form. So I'm just going to leave it as 6 root 2. there, 6 root 2. Then 8.2 says now, calculate theta. That's the angle of inclination. Okay. So calculate theta, the angle of inclination. Now, inclination I get by making tan theta equal to the gradient. So I need the gradient of this line AB. Still the same points. I need the gradient of AB is equal to difference in Y. Once you're comfortable with the formula, it's really not necessary to write the formula first. You can just substitute and continue. Just for the purposes of the learners that's still not comfortable with it, I'm still writing the formula. So difference in Y, -1 minus 5 over difference in X minus 4 minus 2. And I can see this is -6 minus 6, so this gradient is 1. Right, so inclination I get by taking tan theta equal to the gradient, which is 1, and then the theta. If the gradient is positive, you can simply just press shift tan with the gradient to get that theta, which is then 45 degrees. If the gradient was negative, as I said earlier, you can either choose to still use the positive one and then this answer. You take 180 minus this answer, or alternatively, you put in the negative gradient and then plus 180 to that. So just make sure of that. Not applicable in this case though, because the gradient is positive and the angle is acute. Okay, and then 8.3 says write down the gradient of AS. Okay, now AS has this 0.25 there and also this 0.13 there. I don't have the coordinates for S. It's not necessary to go and now somehow struggle and find it's not necessary to find these coordinates. Any 2 points on the line should be able to give you the gradient. It doesn't need to be those 2 points. You can just take any 2 points. I have 2 points, so I'm just going to use those 2 points, A and T, to calculate the gradient of AS here. So 8.3, the gradient of AS is, I'm just going to write the coordinates here for you as well so you can see. The A is 2, 5. And the T there on the sketch is 1, 3. So gradient of AS, yet again, you can write the formula first if you want. If you're very comfortable with substituting into the formulas, you can just substitute straight ahead. So difference in Y, 3 minus 5 over difference in X, 1 minus 2. And then this is -2 over -1, so +2. Okay. This is the gradient of AS. And then next, they say, show that the equation of BC is given by x plus 2y plus 6 is equal to 0. Okay, so BC is this line here, which is perpendicular to that line. And we discussed now earlier that perpendicular lines, the gradients multiplied gives me -1. So the gradient of BC, the equation that I'm trying to find now, times the gradient of AS should be -1 because I have here perpendicular lines. Okay, the gradients multiplied should be -1. So the gradient of BC times the gradient of AS, which I just calculated this as 2. So the gradient of BC times 2 is -1, so the gradient of BC is -1/2. Okay, so that is the gradient of BC, and now you can use either line equation that we used. I explained both of them briefly. Let me go for the one that I don't like. So y minus y1 is equal to mx minus x1. And I'm going to substitute my gradient in there so long. And then I want to also substitute a point there. The x and the y you can keep. So any point that lies on the line BC. Now, on the line BC, the only point that I actually have is that point B, -4, -1. So I'm going to substitute that in there. So the point B, which is -4, -1. I'm going to substitute that in there. So the x is -4. So I'm going to substitute -4 in there. Just be mindful there is a negative and the negative of the x as well. So you will have 2. And same thing here. There's a negative in the formula and the y is -1. So that's going to be 2 negatives there. And then if I now multiply this out and simplify, this becomes y plus 1. This becomes -1/2 x plus 4, and then I multiply this -1/2 in, and I'm going to jump the, let's just keep the 1 first and just multiply on that side first. So -1/2 x, and then -1/2 times 4. If you're not comfortable multiplying fractions and numbers that quickly in your head, use your calculator. Alright, so, and then I'm going to jump the 1 over, so I have -2 -1, so -3, and there's my line equation of BC. Okay. Oh, but they want me to show that the equation of BC is given by x plus 2y plus 6 is 0. So this does not look like that exactly. First of all, they have everything on one side, 0 on the other. So I'm going to bring everything back this side. Y is equal, y plus, let me just write again, y plus of x plus 3 is equal to 0. And now to get rid of the half there, because there's no half in that equation, I'm going to multiply by 2. Then I have 2y plus 1x plus 6 is equal to 0. And 2y plus x plus 6 is equal to 0. That's what they wanted me to show. And then they say here, it feels to me like the camera so close doesn't really focus better and work better, so I'm just going to move it a bit further away again. Sorry for adjusting the camera so much. Okay. That actually seems like you can read clearer now. Who knew? To move the camera further maybe work. Okay, so then lastly, hence determine the coordinates of point C. Okay, now point C on the sketch, let's quickly look. I want to find this point C. Is the point of intersection between BC and AC, which I don't have an equation for, but remember, they gave me the equation of the line through C and T, so I have an equation for that. And well, obviously the line through C and T also goes through there. So to get the intersection point between CT and BC would produce the coordinates of C, which is simultaneous equations on this equation, y is equal to -x plus 4, and this equation. So I'm going to do simultaneous equations on y is equal to -x plus 4, and the equation that I just found now, which is 2y plus x plus 6 is 0. 2y plus x plus 6 is 0. Alright, simultaneous equations. The first thing I need to do is get the x or y alone in my first equation. Y is already alone. Then I can substitute that on the other side. So the y is equal to -x plus 4. I'm going to make this y here also -x plus 4. And then plus x plus 6 is 0. I'm sure most of you are quite comfortable with doing the simultaneous equations, especially with two linear equations. This is no biggie. Minus 2x plus x, 8 and 6 So minus x is minus 14, meaning x is 14. And if I substitute that on this side, I have x, which is 14, plus 4, then y is negative 10. So the coordinates of that point C is going to be x 14, y negative 10. There's the coordinates of C. Okay, and that is question 8. We're going to finalize with number 13, which is a bit of a question on inclination. Here, it's not a very long question, and yeah, it just has these three sizes of angles that they want me to calculate. So they give me this sketch here. There is a B that cuts the x-axis at 4. There is an alpha, there's a beta, sorry. There's an alpha that cuts the x-axis through this line at negative 3. And then this line cuts the y-axis there at 6. This line cuts the y-axis there at 3. And then that angle there is theta. So they want me to calculate the size of alpha, beta, and theta. So we're going to start with the alpha there. This is just to show you, this is a great example of inclination questions. I just want to actually get the sketch there. Okay, you can quickly pause the video maybe and just take a picture or draw the sketch so that you also have a good example of the sketch there in front of you. Okay, because I see it's might a bit blurry from the book. Okay, so the size of alpha there is the first thing that I need to do. But this is a good example of positive gradient, a negative gradient, and an angle that is not an inclination angle, how to get that. So we're going to start with the alpha. The alpha is simply going to be the tan of the gradient. Now you can go and calculate the gradient with the point negative 3, 0, and negative 3, 0, and 0, 3. Calculate the gradient and then tan theta. But I can also see the gradient is difference in y, which this difference in y is 3, over difference in x, and this difference in x is also 3. Can you see that length is 3 and that length is 3? This is positive, so this gradient is 1. I can see that without actually calculating it. But let's quickly calculate it just for those of you that can't see it. Okay, so the gradient of this line, if I work with the coordinates there, it cuts the x-axis at negative 3, so that coordinate is negative 3, 0. And then it cuts the y-axis at 3, so that coordinate looks like that. So what I'm going to do, difference in y, which is 3 minus 0, over difference in x, which is 0 minus negative 3. And then if you type this into your calculator or by head or whatever, you get the gradient is 1. Okay, so this is alpha. Tan alpha is going to be 1, and then alpha is shift tan 1, which is 45, and I have the angle alpha as 45. 13.1.2. The size of beta. So tan beta would be the gradient of that line PQ. Tan beta. This is the angle beta there, the gradient of this line PQ, which cuts the y-axis there at 6 and the x-axis here at 4. So cutting the y-axis at 6 means I have the coordinate 0, 6, and the x-axis at 4, I have the coordinate 4, 0. And this this gradient is going to be difference in y, 0 minus 6, over difference in x, 4 minus 0, and that is then negative 3 over 2. Negative 3 over 2. So what you can do here, tan beta is going to be negative 3 over 2. So beta, and this is what I mean here, I need to take 180 plus shift tan negative 3 over 2. Whenever I have a negative gradient, I must just remember to add 180. Or you can make this a minus and that positive. It will have the same effect. Right. So I'm going to do, because the gradient is negative, if I press shift tan -3/2, I have -56. And if I look at the sketch, my angle of inclination there, that's obviously not -56, right? Do you agree with me? So that must definitely be something else. Okay. So to that -56, if you add 180, that gives you 123.69. So that angle beta is 123.69 degrees. Okay, so alpha 45, beta 123.69, and 13.1.3. Now they want me to calculate the theta. Now, as you can see, hopefully, the theta there, that angle between those two, definitely not an angle of inclination. If I think of drawing a horizontal line there, that's the angle of inclination. So, well, I can actually, from the sketch, it doesn't really matter how you get that. You don't actually need to follow exact Euclidean reasons type thing. I just want to show you where my brain goes with this. Is I draw this line there, and if I look at this angle, it's exactly the same as that angle beta. So from this horizontal line, the beta is the same, but then that theta is made up of this part and that part, the theta. The beta, you see the beta is the same as that if I draw a horizontal line there, because this inclination is the same there and there. I hope you can see what I mean without me actually drawing a line there. And then this little angle here, can you see, is also going to be alpha. So the theta is going to be the beta minus alpha. But that's one way you can look at it. Another way, strictly speaking, mathematically, that you can look at it is the exterior angle of a triangle is equal to the opposite two interiors. So that angle there is equal to beta minus alpha, because beta is alpha plus that. So that angle there is beta minus alpha, and those two are vertically opposite. So theta is also equal to beta minus alpha. So theta is going to be beta minus alpha, and luckily this is analytical geometry, so it's not really expected that you give a valid argument or a reason. As long as you can figure out what to do, it doesn't really matter how you got there. So 123.69 minus the 45, as long as it's I mean, as long as it's a mathematically true statement. So there we go, 78.69, and then I have the theta, and this concludes then the most important crucial parts of grade 10-11 analytical geometry that you need to know. I mean, you can practice a lot of questions and you can come to some things that we haven't covered here, but those are the typical and the most crucial important things of the grade 11 analytical that you need to know.